Hi students, so in this video I'm just doing an extra example here for you that shows you the sum of a geometric series. And this example is a little bit nicer than the previous example on another video that I did. It doesn't involve so many fractions, so that's why I definitely wanted to show you this one. So notice this nicer looking series. Again, we've got a sequence here. 1, 2, 4, 8, 6. Notice you're multiplying by 2 every single time. So that's your geometric sequence. But when you add them together, that sum is called a geometric series. So just reviewing that again. I told you on the other video that we had a formula. We actually have two formulas here. This was the one that you had previously, finding the nth term, okay? So finding the nth term, you have a sub n equals a sub 1 times r to the n minus 1. This is your sum formula. So for your sum of n number of terms in your series, you have a sub 1 times 1 minus r, that's the common ratio, to the nth power. And then that's all over 1 minus r, the common ratio. So there's your formula that you're going to use. So when we did this one, we noticed, when I was looking at this one, we have a sub 1. So here's a sub 1 right there. And then we know this is a sub n. We just don't know how many terms we have here. And then r is equal to 2. So I wrote some of this information down. So on here, a sub 1 equals 1. R you can find by taking, remember, the term and dividing it by the previous term. So in this case, 2 divided by 1 would be 2. And you can kind of see that you multiply by 2 each time. This work here was what I wanted to write down for finding n, finding the number of terms that you're adding together. So we say a sub n, and then we don't know n. We're going to plug in a sub 1, so that's 1. And then we're going to write that multiplied by our common ratio to the n minus 1. Our common ratio is 2. From here, we can use that last term because we want to know how many terms that's going up to. So 512 equals 1 times 2 to the n minus 1. We normally then divide by this number, but since it's just a 1, I just rewrote it as 512 equals 2 to the n minus 1. From here, like in your book, we were told to rewrite the 512 in terms of this base. So we have here base 2. So this 512 can be written as 2 to the 9th power. That's actually what 512 is. So I wrote them with the same base. Once I do that, then I can set these exponents equal to each other. So 9 is equal to n minus 1. And then from there, I have to add 1 to both sides, and I end up getting 10. So that's the number of terms that we have here in our series. We have 10 terms that we're adding together. And so the last step here is finding the sum. And so we're finding the sum of 10 terms. And then again, that's equal to a sub 1, so that's 1, times 1 minus r is 2 to the 10th power. We have 10 terms. All over 1 minus r, and r is 2. Okay? So when we find this answer now, you can actually plug this into your calculator. You're going to get 1 times, and you don't really need to put that, but I'll put that anyway. 1 times. When you plug this in your calculator, you actually get, so look at that right there, 1 minus 2 to the 10th power. That gives you negative 1,023. So negative 1,023 23, okay? And then 1 minus 2 is negative 1. And then the final answer, if you do a negative 1023 by a negative 1, you're going to get 1023. So that's the sum of all 10 terms in this series. So this is a little bit nicer than that other example that we did with fractions. So I hope this helps.